In this example, find the local linear approximation of f of x equal to cosine of x if x is equal to pi over 2. Alright, so I'm looking for the local linear approximation. So what am I looking for? I'm looking for f of x is approximately f at x naught plus f prime at x naught times x minus x naught. Remember my formula? All right, what is my x naught value? What is my particular x value? It's pi over 2. So I could really sub in for this part right now. X minus pi over 2. Now I've got to come up with f at x naught and f prime at x naught. So let's find f of x naught. F of x naught is f at pi over 2 in this case, right? Which is what? Cosine at pi over 2. Think about your unit circle at pi over 2. What's your cosine at pi over 2? That would be 0. So what did I just find? F at x naught is 0. So f of x naught here is 0. So right now I have f of x is approximately 0 plus, now I need to find this part, f prime at x naught. So let's find a derivative. Let's find f prime of x. F prime of x is equal to negative sine of x. And f prime at x naught would be what? Negative sine of pi over 2, since x naught is pi over 2. Well, what's the sign at pi over 2? Isn't that 1? So if I bring down my negative, and this part is 1, I get negative 1. So what's f prime of x naught? Negative 1. Or couldn't I just say f of x is approximately negative x minus pi over 2, like that? And that would be my local linear approximation. All right, part B says, use part A to approximate. Use part A to approximate cosine of 91 degrees. All right, let's keep in mind here, whenever we're dealing with calculus, we're in radians here unless we specify otherwise. So this is given in terms of radians. So what I need to do is I need to convert 91 degrees into radians first. So I'm going to say 91 degrees times pi
Section 3.5
over 180 degrees.
approximation. Let's kind of see a big picture of what we're going to be doing in this section, and then we'll do.
All right, so this will be 91 pi over 180. So what is this? This is just a radian measure equivalent to what? 91 degrees. So to approximate the cosine of 91 degrees, to approximate like what I'm trying to do in part B, I'm going to say f evaluated at 91 degrees is equal to f evaluated at 91 pi over 180. And I'm going to say f evaluated at 91 pi over 180 is going to be given by this formula right here. Negative x minus pi over 2. But what's my x in this case? 91 pi over 180 minus pi over 2. All right, so go ahead and subtract those. Yeah, I'm still in focus. So it's going to be approximately at negative. Now what is this? This is 90 pi over 180, right? So 91 minus 90 will be 1 pi over 180. And then plug this into your calculator. It didn't tell me how far to round on this one, I don't think. No, I'm going to round to several decimal places then. I'm going to say that's approximately negative 0.01745240064. So I'm going to go out a bunch since it didn't tell me how far to round. All right, let's look at the next example. Actually, I'm going to take the last two examples here. I'm going to merge them into one example and call it Part A and Part B, okay? So I'm going to say, use a local linear approximation. Use a local linear approximation to estimate the given values. Or let's put to estimate the values. And let's go ahead and put round final answer to 2 decimal places. Round final answer to 2 decimal places. Answer to 2 decimal places. And just be careful and wily, whatever they tell you to round to that amount. In Part A, we're going to be given 2.97 cubed, okay? So we want to use a local linear approximation to get this value right here. Well, what am I doing? I'm cubing 2.97, right? A much easier thing to do would be to cube 3 and then come up with that value. But the 2.97 makes it a little more difficult to come up with, okay? So what we're going to do is we're going to let f of x be some function here. Usually in the past examples, we've been given f of x. Well, let's come up with our f of x here. What is the operation that's going on? The cubing, right? So I'm going to say let f of x be some number cubed, or x cubed, okay? And let's pick a value of x subscript to 0 or x naught. What do? We pick a value very, very close to x for x naught, right? X value here is 2.97. What's a value very, very close to 2.97 that's easy to calculate with? How about 3? So we're going to let f of x be x cubed, let x naught be 3. All right, so to find my local linear approximation, what am I doing? I'm finding f of x is approximately f at x naught plus f prime at x naught times x minus x naught. Just the formula, right? Well, let's see. I know what this value is. I said that value is 3. So I have x minus 3. Let's find f at x naught. So I'll come over here, I'll say f at x naught is equal to f at 3, which is equal to this function f right here, evaluated at 3. So we'll have 3 cubed. And what is 3 cubed? 27. So f of x naught is 27, so right here I'm going to put in 27. Now what do I still need? F prime at x naught. So let's find f prime of x. F prime of x. F prime of x would be 3x squared, right? Now f prime at x naught, it's going to be the same thing as f prime at, what's my x naught value here? At 3, which will be equal to 3 times 3 squared. In other words, I'm plugging in 3 into that derivative function. What does that give me? That also gives me what? 27. So f prime at x naught is 27. Here is my local linear approximation. Now what do they say? They say use that local linear approximation to estimate the value of 2.97 cubed. So let's see, f at 2.97 is approximately, because remember, if f of x is x cubed, if f of x is x cubed, what is the x? What is the part that's being cubed? Part that's being cubed is 2.97. So x is 2.97, so in place of x, I put in 2.97. It's equal to 27 plus 27 times 2.97 minus 3. And at this point, you can do it by hand or you can put it in a calculator or whatever, okay? So whenever I did this, I got approximately 26.19. 26.19. Alright, so we're going to do the same thing, but this time we're going to call this B, part B. I want to use a local linear approximation to estimate the value of the square root of 48.9. Use a local linear approximation to approximate the square root of 48.9. Alright, so to build my local linear approximation, I need some function f of x. So let me find some function f of x. So what you do here is you say, okay, what operation is being done right here? Square root. So f of x would be the square root of x. And let's let x subscript to be 0 be some value that's close to this value. It's easy to take the square root. What's the number that's closest to this one that's the easiest to take the square root of? That would be 49. Alright, so let's build my local linear approximation. F of x is approximately f at x naught plus f prime at x naught times x minus x naught, right? I know what x naught is. X naught is 49. So x minus 49, I could put in there for the beginning. Let's find f at x naught. F of x naught is like f at what? 49, which is like plugging in 49 into this function, so you have the square root of 49 or 7. So f of x naught is equal to what? 7. Let's find f prime at x naught. So what's f prime of x? If f of x is this, let's take the derivative. Wouldn't that be 1/2 x to the negative 1/2? If you don't see that, just rewrite this as an exponent of 1/2 and do the math there. Alright, so that's 1 over 2 times the square root of x. But if I want f prime at x naught, what I want is f prime of 49. So that'll be equal to taking this f prime value here and sub it in 49 for x. So I get 1 over 2 times 7, or 1 over 14, right? So that's f prime of x naught is 1 over 14. F prime of x naught, 1 over 14. Here is my local linear approximation. But what do they want me to do? They want me to use that to calculate this. Now keep in mind, if f of x is the square root of x, then what would x be in this example? X would be what? 48.9. So right here for this x, I'm going to put in 48.9. So f of 48.9. That's approximately 7 plus 1 over 14 times 48.9 minus 49. And if we end up calculating that, we get about 6.99. There we go, that's local linear approximation.